Hello. This is Mr. Santana, and I just wanted to make sure we go over how to write numbers in scientific notation. As you can see, I have listed here that a number in scientific notation is a product of two factors. In particular, as you can see, it has to be a number between 1 and 10, which would be 1.9, that is between 1 and 10. And then the second factor has to be a power of 10. Now, you know that it's a power of 10 because the 10 has an exponent. So what I'm going to show you here is how to write this number in that fashion. And then I'm going to take this number written in scientific notation, and I'm going to write it in standard notation or standard form, which would look like this. All right, so we're going to take this number, which is 6,054,000,000, and we're going to write it in scientific notation. Right now this is in standard form. So first things first is you need to write a number between 1 and 10. So you're going to look at all of the non-zero digits in your number. Here we have these numbers, which are non-zero digits. I know there's a zero in between, but this one we have to count because it is in between non-zero digits. These on the back end here, we're not going to count because once we make this a decimal, those zeros are going to lose value. All right, so you rewrite this as 6.054. Okay, that is a number definitely between 1 and 10. As you can see, 6 is between 1 and 10. The rest is just a fractional piece of a number. So now I'm going to multiply that by a power of 10. Now, the way to get the exponent is you're going to count how many digits there are after the first number, because what happens is the decimal would normally be here if it were money, right? If we were writing this as money, there would be 2 zeros at the end. So we know that the decimal would be here at the end of this number. So it has to move back all the way between the 6 and the 0. So this is 1 digit, 2, 3, 4, 5, 6, 7, 8, 9 digits that the decimal has to move to get in between the 6 and the 0. So the exponent here is going to be 9. So this number has now been changed to scientific notation, and this is what it would look like. Okay, once again, I don't have to write these zeros at the end because they no longer have a value as a decimal. All right, so same process here. Well, similar, just in reverse, right? Now I want to write it in standard notation. So what we're going to do is we're going to rewrite these numbers, but I'm going to start with just the number 3 because that's my first number, right? Now this exponent here tells me how many digits there should be after the 3. I happen to have 3 digits here already, so I'm literally going to count them as I go. So this is digit number 1, digit number 2, digit number 3. Now you're probably wondering, what do I do now? As you saw in the earlier example, the zeros lost their value, so they were not written after the 4. Here, after the 2, there's some zeros that were not written because they have no value. But now that I need 5 spaces, there's 3, 4, and 5, I have to include the zeros now. So I have this number here. So I'm going to rewrite it just so I can include the commas. And I want you to understand, you always count from the back. You go 3 spaces and you include your comma, then 3 spaces. I don't have to include a comma here because there's no number that precedes the number 3. So this number here, 3.402 times 10 to the 5th power becomes 340,200 in standard form. And that's all you would have to do.